For this example, we want to find the relative extrema of the function f of x equals x squared minus 4 all to the 2/3 power. And we also want to go ahead and locate where the intervals are increasing and decreasing, which is not really any extra work because you have to go through all of that to locate the relative max and mins anyway. So, what do we do first? Take the derivative. So we have f prime of x equals 2/3 down 1 on the power times the derivative of the inside, which is 2x. And we'll clean that up. And that gives us 4x all over 3 cube roots of x squared minus 4. Any questions about the derivative? So now we just need to set the top and bottom equal to 0 and locate our critical numbers. 4x equals 0. So one critical number is going to be 0. And for the bottom, we have 3 cube roots of x squared minus 4. Set that equal to 0. The cube root of x squared minus 4. Cube both sides. X squared minus 4 equals 0. So x is plus or minus what? Alright, so we have 3 critical numbers. We don't have any limit. It's not like a trig problem. We're not doing just from 0 to 2 pi. We're going from negative infinity to positive infinity. So we'll let this represent negative infinity, this represent positive infinity, and we will break it at -2, at 0, at +2. And then we will pick numbers in each interval and test them into our first derivative to see if it is increasing or decreasing. So we'll make a test. We'll do -3. How about -1, +1, and +3? So we'll pause right here and let everybody do their tests themselves and make sure we all get the same intervals for increasing and decreasing. So when we substitute -3 into the derivative right here, I got -2.3. Did you guys get that? Mm-hmm. So it is decreasing from here to here. When I substituted in -1, I got +0.9. So it is increasing between -2 and 0. When I substituted +1 in, I got -0.9. So it is decreasing again from 0 to 2. And then when we substitute +3 in, we get +2.3. So it is increasing again from 2 to infinity. So far, so good? Mm-hmm. Okay. So let's go ahead and let's list our intervals where it's increasing. And that is from -2 to 0 and from 2 to infinity. And it is decreasing from -infinity to -2 and from 0 to +2. So there's half of our problem. Now we just need to decide if we have any relative extrema. If this is a relative extrema, it will be a relative minimum. This will be a maximum, and this would be a minimum. They don't always have to be relative max or mins, even if the derivative changes. If you get undefined when you substitute back into the original, that means it's not really a relative max or min. It's either a hole in the graph or it's an asymptote or something. And we'll look at examples of those as we go. All right, so right now it looks like I have 2 relative mins. They are happening at -2 and at +2. And remember, we just plugged those into the original. So if I plug -2 into the original, what do I get?
0.
0. And if I plug +2 into the original, I also get 0. So they are my relative minimums, and you are allowed to have multiple. And then for our relative max, it looks like we only have one at 0, comma something.
2.520.
Yeah. If I plug it in and I get the exact, I have -4 to the 2/3 power, which would be the cube root of -4 squared. So the cube root of 16, right? Cube root of 16, you guys? Or if you want to give that as a decimal, what do you get?
2.520.
2.520. And that's how we find relative max and mins. We want to do the same thing for this function. So we have f of x equals x to the fourth plus 1 all over x squared. And because we're dividing by a monomial, we're just going to split it up rather than using the quotient rule. So that will give us x squared plus 1 over x squared, which is the same as x squared plus 1x to the negative 2. We make it a lot easier for us to find our derivative. So for our derivative, we get 2x minus 2x to the negative what? To the negative 3? Yeah. Which is going to be 2x minus 2 over x cubed. And then we'll get a common denominator of x cubed. And we have 2x to the fourth minus 2 all over x cubed. And it really will help if you will somehow either highlight or bubble in that first derivative, because you're going to be using it a lot to substitute back in. So to find our critical numbers, we'll set the top equal to 0. And we'll solve them. So do we agree that on top we just get plus or minus 1? Because this one right here would produce an imaginary. So you're only going to get positive or negative 1. You're not going to use imaginary critical numbers. So there are 2 spots in my number line. And the denominator is just going to give us what? 0, yeah. If we have x cubed equals 0, we cube root both sides, we just get x equals 0. So we're going to break our sign line up at negative 1, 0, and positive 1. So we're going to go ahead and we're going to test some numbers into our derivative. So how about if we test negative 2, negative 1/2, positive 1/2, and positive 2. And remember that we put these into the derivative to see if the derivative is positive or negative. So we'll pause here and give everybody a chance to do that. So when we substitute into the derivative, negative 2 produces negative 15 over 4. Negative 1/2 gives me positive 15. Positive 1/2 gives us negative 15. And positive 2 gives us positive 15 fourths again. Do you know what that's called? See how those guys have the same values, but opposites? That's origin symmetry when you see that happen. So you can kind of recognize it from a table. All right, let's see. So this is negative, this is positive, this is negative, and this is positive. So where am I increasing? From negative 1 to 0 and from 1 to positive infinity. And we are decreasing from negative infinity to negative 1. Great. And 0 to 1. Perfect. And if I have relative extrema, it looks like this would be a relative minimum. This would be a relative maximum, right? And this would be a relative minimum. Now that's not always true. That's what it just looks like so far. To be sure, we have to substitute those values back into the original and make sure they're not undefined. So I think I'm going to have a relative min at negative 1 comma something and positive 1 comma something. So if we plug negative 1 into the original, you guys said we get what? 2?
2 for both of them.
Oh, great. And then if we plug positive 1 in, we get 2 as well. Are you guys okay with that? All right. And then relative maximum. What happens when you try to plug what appears to be a relative max in? Yeah, you get undefined as your y value. And what that's telling you is either there's a hole there or an asymptote there. And you can look at this graph and this original and you can tell that there's a vertical asymptote at 0. So we just say it has none because it didn't actually produce one. So just because it looked like it had a relative max there doesn't mean it had to. So be very cautious. Asymptotes will produce undefined spots there. So the problem set for this is just 13 through 37 odd.